Second rule is raising a product to a power. So that means you have parentheses with more than one base in it and an exponent on the outside. Okay? So if we were to expand this out, this would really be 3x times 3x times 3x times 3x. So it would be 3 to the 4th power and x to the 4th power. You've multiplied 3 4 times, right?
Yeah.
And you've multiplied x 4 times. And 3 to the 4th is 81. Okay. Now, again, the intention is not that you expand these out. We have those rules to save you the trouble. If you look at this down to that, okay, what happened when we took the parentheses away, every base that is in parentheses gets that exponent. Okay, so if you have, so the rule is if you have a, b to the m power, then that becomes a to the m, b to the m. People seem to struggle with this one. They will call it 3x to the 4th. They don't bring the exponent to the 3. And you're missing the whole rule if you do that. There'd be no purpose in the parentheses if that were just 3x to the 4th, right?
So what about the ones like that are like that, the ones that we learned earlier? Do we still do
Yeah,
that?
you still have to follow the other rules, okay? So here's what happens. Say that one of those bases already has an exponent. Okay, then the rule that you just learned applies. So this would become 2 squared times x to the 4th squared. All right? Now, you don't necessarily have to write it this way. But just because these are your notes, I want you to understand this is the power to a power that you just wrote down a minute ago. So that would become 2 squared is 4. 1 base, 1 mark would be x to the 8th.
Still simple enough.
Not bad. Okay. Okay, so let's look at one with a negative exponent. So this, I would apply this first, okay? Not evaluate, but just apply it. So this would be 4 to the negative 2, g to the negative 10. So you can skip this. You don't have to show the power to a power unless it helps you. I mean, at every step that helps you, you should do it. But then these are both negative, right? And before I evaluate a negative exponent on a number, I move it. That is not negative 16. Everything moves because it's negative. So it'd be 1 over 4 squared g to the 10th. Now, at this point, if you're looking at it and you know what 4 squared is, you don't have to show it as being positive on the bottom. You can put 16 as long as you move it. Okay, so that would be 1 over 16g to the 10th. So you're starting to get a little taste of what happens when we throw these rules in together. Okay. So I'm going to give you a couple that are more complicated.
Oh.
Now, in order to not get overwhelmed by what's sitting in front of you, you take care of one thing at a time. Some of the stuff, you could go either way, okay? But when you have exponents on the outside of parentheses, you have to take care of those before you apply other rules, okay? So, you're going to apply the power to a power first. Okay, that is one that is a must do. So I'm going to get rid of those first before I worry about anything else. Okay, so this would become x to the negative 4, and you can put a times in there because you're going to drop those parentheses. Now remember, somehow these strings of bases people lose track of. I've had people do the first and the third, but not the second. I've had people not do the number because it's a number. Every base gets that power. Okay, so once I drop those parentheses, I should have 3 to the 4th, x to the 4th, y to the 8th. We just go right down the row. Everything you see in those parentheses gets that exponent, okay? Now, you should be noticing I've got 2 things that I've got to take care of. I see x more than once, and I have a number to a power, okay? So, if I take care of the fact that x is there more than once, what's the rule when I have 2 bases? Atom, okay? So I'm going to reorder. You don't have to do this, but I have 3 to the 4th, x to the negative 4th times x to the 4th, and then y to the 8th. If I add these, I get 0, right?
Yeah.
And anything to the 0 power is 1. So these will cancel. But if you forget and you go 3 to the 4th, x to the 0, y to the 8th, then you should get rid of that. We don't need it. Okay, one last thing to take care of is the 3 to the 4th. And you could have done that really here or here. But this is going to be 81 y to the 8th. The key to these, like I said, and the trick to not getting overwhelmed is you take care of one thing at a time, and then you look at it again and go, is there anything still that I have to fix? And you fix it, and you look at it again, and if you feel like you've taken care of everything, then that's probably when you're done, okay? But try not to fix everything in one shot. All right, so let's do this one. Tino? Should be writing these down. Okay. Should be trying it. Did you come up with an answer for this one? Yes. So what I would probably look for as your second step, if I were looking at your work, is that you'd have 6 to the third, m to the third, n to the third, times 5 squared, m to the negative 6. Okay, if you did that, if that's what you had next, so far so good. Okay, I would then figure out what 6 to the third is. 216. Okay, now at this point, you know that that number is going to have to come in front, okay? But we need to do 5 squared, so that's going to be times 5 squared, which is 25. Now I have my m's. If it helps you to write them next to each other first, then do that. So it'd be m to the third times m to the negative 6, and n to the third would go last. You can at this point do 216 times 25, which would be 5,400. We would add those, 2 bases, 2 marks. So that would be negative 3. Now it's your choice. If you want to move this down immediately, because there's no other m, you could do that. But that would be m to the 3, or negative 3n to the third. And if you didn't move it down in this step, that's the only thing you have to fix for the last step. So that would be 5,400 n to the third over m to the third. Okay, remember the 5,400 does not move. That does not have a negative exponent. All right. And I lied on the scientific notation. There is one application, just one. Okay, so scientific notation. Oh, because I love
She
you.
isn't that bad. Miss Charlie.
Okay. So you have to think in terms of bases, powers, product to a power, okay? This is just part of your scientific notation. This would actually be 1 times 10 to the negative third, technically. It's this that you need to worry about, because this is a product to a power, okay? You have 2 bases with an exponent out here. So that means both of these get that power.
Wait, what's the power on 3?
1.
3x.
Now it's 3 times. This is scientific notation. Remember, that's not an x.
Oh, yeah, okay.
That's the multiplication symbol. Okay, so this would be 10 to the negative third times 3 squared, right? 3 squared, which is 9, times, so remember, it's scientific notation, x is multiplication. So one time we do that in algebra. 10 to the 8th squared, you multiply, so that would be 10 to the 16th. Okay, so you've got 2 powers of 10 here. We add them. So this and this get added. So this would be 9 times 10 to the negative 3 plus 16.
13.
So 9 times 10 to the 13th. And as usual, you check to make sure that this is between 1 and 10. Make adjustments, because your answer, anything that you're doing with scientific notation, besides converting to standard or scientific, your answer is going to be in scientific, okay? So you should not be taking these and writing them out in huge numbers. Okay, so that is the answer there, all right?
And we're done on those?
Yep, we're done on those. Okay, this also is two-sided, so your 8-5 is on the back. Okay, for later, you don't need to do the opposite side today. Just make
Oh my goodness. Is that the right one? I think I didn't do it.